Hello comrades on the other side of the internet. It is your friend, your host, this guy with the thumbs, Brandon Hart, the Eco-Extruder. And it's this video is a little overdue, I suppose, at this point, but you've been following me as I've done a lot of the building on the BIG-60, pretty much from the beginning, from the unboxing. If you haven't, by the way, then check out the link in the description and maybe up somewhere on the screen here too, so you can see what that process looks like. But for those of you who were always the type to skip to the end of the book and just want to know how everything wraps up, this is your video. So I've got the BIG-60 obviously fully built, totally completed, and have been running some test prints through it, as well as some final prints, some actual customer print jobs and things like that too. So got a fair amount of experience. At this point, I'm not going to call this a full review. I will be running through a lot of my thoughts on the machine, both the build process, the kind of the final end result, what I have, and whether it's something that I would recommend. But I'm going to stop short of calling it a full review, simply because I feel like so far I've only run PLA through it. And I feel like to do a true review, I need to really put it through a lot more paces. Different materials. I have printed with different types of nozzles. I would like to, really kind of beat it up and see how fast it can go. Things like that. And I haven't necessarily gotten quite that far with it. So I'm going to call this my build wrap-up and initial thoughts video. So you probably already know that from reading the title. But anyway, so let's do that. So first off, when we left off in the last video, I had finished building the machine itself, but I still had to do things like calibration and dialing it in and setting different Z offsets and stuff like that. So I did take some footage of that. This is hard to make fun and interesting. So I'm just going to roll some of this footage at high speed, but what you're seeing is initially I had to get the PID controller for the bed heater, which is a 110, 120 volt direct AC powered bed heater, get it dialed in so that it could always maintain the proper temperature. At first I had a lot of trouble with this, just trying to get it set up right, but mostly it was because I didn't trust the instructions to walk me through it properly. After I decided, okay, well, I'll just do what the instructions say, then yeah, everything worked out great. The PID controller auto-tuned itself, and after that point, it has been basically flawless. Once I set it to a particular temperature and hit go, it goes to that temperature, maintains that temperature. So calibration, follow the instructions, and you'll be good to go. The one thing I did have trouble with, as you can see, is I was filming this, so I have a lot of lights pointed at it, and it's sort of hard to read that little display because of that. After that, it was a matter of trying to make sure that the bed was level from side to side and front to back. So that involved a lot of manually turning the ball screws. There are 3 of them, so there's one as you face the machine, there's one on the left and 2 on the right. And so by changing them left to right, that obviously can get you the X axis, and then by messing with the 2 on the right, the front and the back one, then you can get the Y axis pretty well leveled out. I have to say, after I got everything leveled, I was able to move the print head around the bed, and it maintained a very, very good distance from the bed, very consistent across the entire bed, so the bed itself was nice and flat. Next step after getting it flat, of course, is to determine the Z offset. So how far from the bed should the nozzle be, and what is 0? What is the printing height that you want to set up and maintain? So there's a lot of trial and error involved in this process, kind of dialing it in. I don't think this is really any different than most machines though, at least those that you have to build yourself, to kind of calibrate that offset. But once the offset was calibrated, it was straight into doing the unified bed mesh leveling, or UBL, unified bed leveling, which is a built-in process that you essentially just enable. It's part of Marlin, and it'll go around the bed and probe, I think it's 100 different points across the bed, and determine any little deviation, any changes in how it works. Have to do this with a hot bed, have to do this with a hot nozzle, so that any thermal expansion that happens when you heat these things up is taken into account. But then once you do that, it saves all of those points that it measured into memory, and will reference that from that point forward with any future prints. So as it travels to a specific part of the bed, it knows how much to compensate for any deviations in the bed itself. There's one final step in the instructions which says to use a calculator provided by Modix to tweak any little things. You can see the sort of the spiral, or it's not really even a spiral, the concentric squares that I printed on the bed. That is to allow you to manually go in and calculate differences between what the UBL figured out and real world. I didn't find that necessary. So once I printed those concentric squares, I just said, yeah, it looks good. And I skipped straight ahead to doing some test prints. Speaking of test prints, that is the exciting part of all of this. So what I'm showing now is some footage of the very, very first print that I ever tried to do. So this was taking a very small coaster, and I'm gonna grab one. Taking one of these little coasters here and scaling it up 400%. These are just little coasters I designed and printed out on another machine for use around the house. But I scaled that up 400% and a 200 micron layer resolution using PLA. I think it was something like 10 to 15% infill and 2 or 3 walls. And just let it go. Basically default Simplify 3D configurations. You can see also in the video footage here that I did set up Simplify 3D with the appropriate profiles that were provided by Modix. And once I got all of that dialed in, I went ahead and did the print. And not to spoil anything coming up, but here's the original and here's the 400% version. And I do want to stress, this was printed with the default settings that were provided by Modix and Simplify 3D, and a 200 micron resolution, and was the very first thing I printed after I got the machine dialed in. I got it built, got it calibrated. I printed this straight away. There was no warping at all. It's not perfect. I'll show some close-ups of this. It's not perfect. A little under extruded in a lot of spots, but again, that's not the machine, that's the settings. So a little bit of tweaking and all of this will fill in quite nicely. But I mean, straight after building the machine, right? That's pretty impressive. So needless to say, quite happy with that. Speaking of my thoughts, of my feelings on all of this stuff, I took notes. So bear with me as I kind of flip through them here real quick. But, you know, so that's the end of calibration. That's the end of dialing things in. Once I got that first test print done, I said, yes, it is ready to go. And then I just started running some additional prints through it. Well, let's just show some of those test prints. So the second print that I did was I grabbed a full 1 kilogram spool of materials, some real cheap material, and you can sort of tell by the color variation. Hold this up to the light a little bit. The color variation there. This was not very well made. It had nothing to do with the way the machine performed. The machine gave me nice, smooth layers there. But I went ahead and put a 0.8 millimeter nozzle in to print this one, so I could test out moving a lot of material through it really, really fast. So this is a full 1 kilogram spool of PLA, and I just let it go. It's a base mode print, and off it went, and it came out pretty darn well. Again, little bit of under extrusion there, but that's, I think, more less about under extrusion and more about overlap for the infill. But man, I mean, I blew through this entire kilogram of spool in less than 24 hours to print this thing out. So it was moving, and pretty darn happy with it. It looks super cool. Let's see, next thing. I show this dual bearing gear thing off quite a bit because it's a nice example of what 3D printing can do that other manufacturing cannot. This is printed just as it is and built up layer by layer so that all of the gears are actually trapped in a sort of a herringbone gear pattern here. They're trapped inside of the assembly. You can't put this together after the fact. A really cool model, found it on Thingiverse. So I like to show this off a lot, but I thought what would be cooler is a bigger version. So I kind of feel like this might be a trend, finding cool models out there and doing a bigger version. But yeah, so this is a bigger version of the dual gear bearing, I think is what it's called. And I printed this one also, real thick, chunky layers. This was 0.6 millimeter layers with a 0.8 millimeter nozzle. This is actually with the Olsen Ruby nozzle. And I wanted to see what it would look like. How fast could I print this out? Again, full kilogram of material. Less than 24 hours, I believe, to print this one as well. But, I mean, sorry that's loud, but it works amazingly well. I'll show you some video of me taking it off the print bed, and I'll give you some close-ups here of the print quality. But again, nothing to be upset about there. Then I switched back to the standard 0.4 millimeter nozzle to use up some material. So I found these Nautilus gears on Thingiverse and printed those out as well. Again, just a touch of under extrusion, so I didn't quite compensate well enough after doing that first test print. Just a touch of under extrusion, but I mean, you know, it's really nice build quality for a print like that. So those are the test prints. So all of those, I hope you would agree, very, very nice, very acceptable quality, if not better, on those prints. I was tempted to do some small detailed prints just to see how well the linear rails and the the belt setup and everything were able to handle tiny little movements. But the truth is, it's kind of irrelevant. This is not a machine that you print tiny little figurines out on. If that's the intention, this is the wrong machine for you. So I've got many other machines, and I run those machines when I need the small detailed items. This is a machine made for big things. It's made to print big things. It is in the name. It is the BIG-60. So why are we even thinking about trying to print small little detailed things on a machine like this? So I haven't done that, and I don't think I will. I've even thought about swapping out the Volcano for a standard V6 nozzle and putting a standard V6 heater block and putting a standard nozzle in there. I don't think I'm going to do that though, because that's not what this machine is built for. So I don't know, we'll see. Maybe I'll do that at some point, but for right now, I don't see the point. All right, so there were the initial prints. Let me give you some thoughts and kind of run down where I'm at. Sorry, this is going to be a lot of rambling, but that's sort of what this video is all about, so bear with me. All right, the build process. So, actually building the machine. You saw a lot of what I went through. You saw some of the good, some of the bad, some of the stuff that I would have personally liked to see changed. But just to give you a quick rundown, the build process itself was quite well documented. I have built multiple machines in the past. None quite this big, but I will say that the documentation was quite good. Couple complaints, there's definitely some room for improvement. Some of the pictures don't necessarily match the current version of the machine. They're from version 1, and this is a version 2. So that's kind of an issue. The other issues are that none of the pictures, so they have pictures on the online documentation that show you what you're supposed to be putting together. None of those pictures are clickable. I want to blow them up. I want to look closer at exactly, where is that screw going? Or is there a washer underneath that screw head? And you can't see that from the pictures. The 3D CAD models that you can move around in Fusion 360, essentially, the online version, A360, whatever it's called, that's awesome too, but a lot of the connectors and the fasteners and some of the detail is missing. Those details are important because those details tell me exactly how I'm supposed to be putting stuff together, not just sort of where in space it belongs. So I would have liked to see a little bit more detail. Now that was going to take longer to load and then slow everything down, so I kind of get why that's not there, but it's not terribly helpful without that. Videos. Short little videos kind of showing how certain things go together would be great. I think there may have been 1 or 2, but not very many. And so having short little, 10, 30-second video clips showing how certain things go together would be really great. There was also some consistency issues. The beginning was very, very detailed on how everything was supposed to work. Toward the end, it got really sparse. It just kind of said, put some stuff together. But that was about it. Little issues with the consistency, but overall, I mean, these are, I hope you can tell, minor issues with the build process. Okay, so enough about the instructions, the actual parts themselves. So, as you saw in the second video, the Z extrusions, the Z profiles, were not cut correctly, so I had to get replacement Z profiles. And then when I did get the replacements, some of those weren't drilled properly. So there were a few issues with parts that were not quite right. The dual extruder, the second hot end mounting bracket was wrong. But the one thing I have to say, which I'm very impressed by, is that while some of the parts may have been wrong, there were no missing parts at all. That's crazy. There were a ton of parts that come as a part of this machine, and there was not a single missing part in the bunch. Some of the build instructions had me using the wrong screws, and so I couldn't find those screws. That was an instructions issue. The parts themselves were all here, and everything was included that I needed to build the machine. Awesome. That has never happened in all the machines I've built before. In fact, there were actually some extra parts that were included. So these are the original version 1 belts. These belts are no good. I mean, you can tell sort of just by feeling them and looking at them, they're not very good. They were replaced with genuine Gates belts. The pictures showed the old belts, the white belts, instead of the Gates belts, but actually in my kit, both belts were included. So I actually got extra instead of having too few. All of the parts themselves, the genuine high wind rails, the Gates belts, the drag chains, the bed, the extrusions, everything is very, very high quality. I love the genuine E3D Titans for the extruders, the Volcano, the nozzles. The whole motion system is really, really good. The ball screws, I mean, everything is just really, really nice and very, very high quality parts. And so even if there was something later that I wanted to change, and knowing me, that absolutely will be the case. More on that in a little bit. The parts that I would be using would be in addition to these parts, not necessarily instead of a lot of these parts, because they are very high quality and they're very, very good. Another thing that never happens in a lot of these kits is the wiring. So I'm not going to take the time to open this up, but I'll show you some pictures. All of the wires are terminated, they have connectors on them, and are labeled. So simple and yet so awesome. Everything is cut to length, everything makes sense and where it goes. They all have connectors and terminals or something like that on them, and they are labeled. So you don't have to put multimeters on one wire and see where, which other end of the wire is connected to that wire, etc. That's just so wonderful as somebody who's building these machines, just to know that everything goes together, that everything connects properly. And this is also the very first machine I've ever built where the wiring worked properly the very first time. No reversed motors or anything like that. As soon as I got everything wired up and plugged in, I fired it up, everything moved the way it was supposed to, everything went the directions they were supposed to, no error messages showing up on the screen. That's just awesome. I love that. Fantastic. So that's kind of my thoughts on the build process itself. Overall, it took a long time. It wouldn't have taken nearly as long if I wasn't trying to record everything, because setting all this stuff up and getting the lighting and everything in place, getting the microphone connected, all that takes a very long time. And so don't go by my videos as far as how long this build process took, but there were a lot of steps and there was a lot to do. Okay, so let's get into thoughts on the machine itself. So first off, something a lot of people wonder about is this big aluminum bed. That bed is a common source of concern, because when you get a bed that's this big, it often tends to be a little bit warped or not completely flat, or it's hard to get level and that kind of stuff. In fact, in the version 1 of these machines, I think actually I have read several people having problems with the aluminum beds. I have to say, it is milled down extremely flat. This bed, I mentioned earlier when I ran the nozzle across it, there were no inconsistencies, no issues really with it at all. And as far as heating it up, it is a very large piece of aluminum, and so having that direct 110, 120 volt power is great because it heats up much, much faster. It also heats up very consistently. This was another improvement from version 1 over version 2. Or sorry, version 2 over version 1. You know what I mean. But I had a buddy who brought over a FLIR camera, and we checked the bed heater and to see how consistent, see how even it was. And there are always going to be deviations, so you can't totally go by the colors here, but the consistency in the middle of the bed versus the edges, especially where this 2020 extrusion goes, there was a lot of concern about the heat sort of being synced into the frame, into that 2020 extrusion. There's a little bit of that, but really not nearly as much as we expected. So that's really, really nice. One thing I don't care for much is this grounding wire. It attaches to one of the conical flathead hex bolts that holds the bed down to the frame, and there's no way to avoid having it sticking up on top of the bed, which, especially in the dual extruder setup, means that that second head in particular is going to contact that bolt, and that's going to be a problem. Especially and the induction bed sensor being right next to and sort of behind the primary print head too, also means that when it's trying to do the UBL and determine its level, it's going to sense that sticking up there. So not a big fan of that. I think the only way to really fix that though is if you were to drill and tap the side of the plate and have it screwed in there, because otherwise, I mean, you can't stick it underneath the bed, and there's really no other good way to connect it. So it's not a great thing, but it's also not awful. It's in the far corner, so no big deal there. The bed is independently controlled. So this interface right down here is the only interface for the bed. There is no control from the screen or from your G-code for the bed itself. You're going to be running long, big prints on this thing, maybe a week at a time or more. What you don't necessarily want is maybe you're out of town, like I am a lot. Start a print, make sure everything's going well, leave town. I have other people around, so don't worry. But you know, it's not a great idea to have this big, massive, high-powered, heated bed sitting there just constantly being heated after the print is done for maybe days at a time. That's a lot of power and a lot of energy that is being used for no good reason. Additionally, a lot of these surfaces, especially the PEI that it comes with, are meant to release when they're cold. If it stays hot until you come over and turn it off so that you can take the part off, it takes quite a while for it to cool back down to the point where the bed surface releases the part. So it's sort of a waste of time in addition to a waste of energy. So there are certain things that you can do to help out with that. One of the things that I plan to do is hook up one of these power switch tails, and you can essentially just run a control line from the main electronics board, from an I/O, into the power switch tail, and it just turns off the power to the bed. Just cuts it off entirely. I've done that kind of thing before. Works pretty well. The only issue is that you have to have your G-code start the bed warming. Basically flip that I/O high before you can start the print. So sometimes it's not quite ready to print by the time the print head and the G-code is ready to go. But you know, again, really not a big deal. The print surface itself on the bed, you know, I'm trying to use some of these bed surface, you know, the things that you apply out of a roll-on or you know, with a sponge. I don't like them very much so far. I really would like to have a removable bed rather than taking the PEI sheet that comes with it and just sticking it down directly onto the bed itself, because that stuff does start to bubble over time, especially as parts grab it and pull on it while the bed is hot. It just inevitably starts to form air pockets. So that is all still kind of TBD. I'm trying to get by with these bed surface things that you apply directly to the aluminum plate. It works okay, as you can see, but not great, and it's rather expensive. So I may just end up deciding to forget it all and put the PEI that came with it right down on the plate, like I've been trying to avoid to do. Alright, so that's the bed. The enclosure. The enclosure is, you know, it's pretty nice. You know, it's got a hinged top on it. It's got these, you know, doors so that you can access the inside as necessary. It fits quite well around everything. So overall, I'd say it's pretty decent. These doors are thicker than the rest of it, but the rest of it, I don't know if you can see it here, but the rest of it's pretty thin. It's not real thick. So I don't know how much heat it's really going to keep in, and I get concerned every once in a while about, you know, accidentally kicking the side or who knows what, and the whole thing just cracking. I've had thicker acrylic for some of the other enclosures for my machines, and it has cracked. So still a little bit concerned about how thin those are, but we'll see. Maybe it won't be such a big deal. It does tend to get in the way a little bit. So you can fold this top back, but you know, the home position for the print head is way back here, which I can't get to, you know, unless I do what I was just showing you. But usually I'm here working on the machine and I want to do some stuff up here, but the print head and everything is way back in here, so it's really kind of awkward. It's a little low. I wish it was a bit higher so that I would have a little bit more headroom to kind of get in and work on stuff. That would also help with this really awkward peak DFE tube. You know, it just sort of gets wrapped around and twisted up. Whereas if it was higher, I feel like that would be less of an issue. So the enclosure top, I don't love as much as the rest of the enclosure. The rest of it's pretty decent. So that, you know, not too bad overall. The motion system itself, you know, again, I mentioned the belts, I mentioned the linear rails, I mentioned the ball screws. They're really nice. I mean, the machine is quite smooth as it operates, as it moves the head around. I haven't seen really much ghosting or you know, any artifacts in the printing of the motion system not being accurate or precise. So, really dig the motion system itself. This screen, I don't love this screen. It is pretty old school. This is the same screen that I've got on a lot of the machines that I built 5 years ago. So I don't love that. I know Modix has been working on touchscreens and they're trying to come up with the right solution for a touchscreen, but it's in desperate need. This is a big machine. Having a screen like that just cheapens it all. So it's a minor issue again because it doesn't actually affect the performance of the machine, but I don't like this machine, or I like this screen. What I like even less is the fact that the screen is down there. I mean, for reference, I'm 6'4", so this is kind of the machine height. When I'm working on the machine, you know, I'm going to be here. I'm not going to be down there. So a lot of times I have to squat down. I've got bad knees, so I don't love doing that. Or I end up just kind of doing this to try to figure out how to work with it. That is the wrong height. Now, I will say, I see on a lot of the newer pictures that are posted on the Modix website, that instead of this being down here, it's up here. Much better. So your machine, if you end up getting one after I got mine built, your screen is probably up here now, which is a way better place to put it. Still wish it was a better screen, but you know, as long as it works, it's fine. The wiring. So there are a lot of wires, as you might imagine, for a machine like this. But the wires are handled really, really well. So everything is well routed. There are these covers that go over everything and hide it all in the extrusions. So there's lots of channels. Even the enclosure has little gaps and spots where the wire is supposed to go through. So all of that is really, really nice. The wiring is handled very, very well. The cable management, the wire management, the wire routing, all just makes sense in where things have to go. You generally don't see cables too much running throughout a machine like this. And I know in some lower cost machines, in particular, it can just be a rat's nest. It can just be awful. The wires hanging out everywhere. It's nasty. But in this case, that's not at all the case. Let's talk dual extruder. I'm just gonna go ahead and say right up front, if you get this machine, don't get it for dual extrusion. I've used dual extrusion machines in the past that have a similar side-by-side head, print head setup, and it is worthless. I mean, it's just, that's the only way I can say it. It's worthless. Having that second head just sitting there, essentially oozing the whole time, or trying to figure out how to turn it off and back on again. Maybe printing ooze shields to help try to block that. None of that stuff is worth anything. It's never going to result in a good, clean print. I have gotten okay results in the past with other machines that have that dual side-by-side head setup, and it's just so much work, it's not even worth it. So after going ahead and building it as a dual extruder machine, you can see I've still got the second Bowden extruder set up here, but I don't have the print head installed anymore, or the hot end installed anymore. I just took it off. Never ran a millimeter of filament through it, but I knew just from working with other machines that have the same type of setup, I was never gonna be happy with it, and so I just took it off entirely. Also took off the second spool holder that goes here. It's actually right here. So, no point. Not even gonna bother. But, you know, maybe if you want to struggle with it, you can, but my recommendation is just don't even bother getting the dual extruder set up at all and stick with it as a single extruder. Hopefully there will be more multi-material options coming soon, but as of right now, single. The filament sensors. So sort of show the side here. The filament sensors on this machine are awesome. So I meant to test it, didn't actually intentionally test it, but actually ran out of filament, and it just paused the print, it parked the head, and it waited for me, it cooled everything down, and it waited for me to come back and put more filament in it. That's how it should be handled. That is excellent. Very, very well done. I have to say, as simple as these little spool holders are, yeah, there you can see it. You know, it's just basically a little tube that's screwed into a bracket. This is great. I mean, this really works well. It's pretty steady, and I like it. We just lost our lights. Hang on. There we go. Motion sensors. But yeah, so pretty well dig the spool holders. However, one thing I don't dig is these tubes. You can see, even just as I've been trying to show the machine, I've been having to struggle with this floppy bit of mess. You can, you know, put these in different spaces, in different places, but as the print head moves around, it just doesn't really help much. The PTFE that came with it, this is not the PTFE that came with it. This is a 1.75 millimeter PTFE inner diameter. I think it's probably 1.8 technically. It's too small, and there's no point in a system where you've got the extruder directly above the hot end. There's no point in having such small PTFE. There's a lot of friction as you try to move filament through that tube for no good reason. So I went out and I bought PTFE that's meant for 3 millimeter filament, and I've been running stuff through that ever since. Works much, much better. The only issue now though is that this little coupler here, the PTFE holder, doesn't fit. So this just sort of hangs out there. Not a big deal, but would like it if that was connected. So PTFE is a little awkward. The power switch. So when I swapped out nozzles and I took off the second hot end, I had to kind of go through the calibration process all over again. And I changed where the induction sensor was. I had it a little too high, and when I was trying to calibrate my Z offset, I crashed my head I crashed the nozzle into the print bed, which wouldn't have been such a big deal if I just flipped the power switch. Unfortunately, the power switch is not here. Power switch is way back here, and the power switch is blocked by the spool. So trying to dive for that power switch to turn off the machine so that it stops crashing the head is not a simple thing to do. I truly wish that there was one of those big emergency stop buttons on the front, you know, or just that the power switch, you know, was somewhere accessible when you're working on the machine. Having it way back here doesn't make a lot of sense to me. I'm gonna get, from an electrical standpoint, why that's the place where it goes. I just don't like it very much. So, the other thing is, this thing very much is begging for lighting. It doesn't have any lights inside at all. And especially, look, I mean, you've got this nice cutout that's red, translucent, acrylic there. It's begging for lighting behind it. And this big area here needs some lights as well. So I've got some of these cheap LED strips that I will most likely be putting in here very shortly. So that's needed very much for getting everything working, or just making it more convenient. Right on. Well, I think I'm going to cut it off there. I have some thoughts on some upgrades and stuff like that that I'd like to do at some point, but maybe I'll make a separate video on that. I feel like I have been talking for literally ever. All right, well, maybe not literally, but for a long time, and I think that's about all that I can expect people to take. So, in summary, it's a great machine, especially for the price. I'm really quite happy with it. I can't wait to run some more engineering grade materials through it, some nylon, some polycarbonate, some composites like carbon fiber nylon and stuff like that, and see how it holds up to all of that. There are plenty of things that I want to do to kit it out and kind of go a little bit nuts with it. I already got a Olsen ruby nozzle, as I mentioned, so you know, I've outfitted it with gemstones and some bling, but there's a lot more that I want to do. So yeah, pretty happy with it, pretty pleased. It does take some time to build and to calibrate and get dialed in, but once you do, it holds its calibration really, really well. Besides making the changes and then having to kind of rerun the UBL, you know, I would have never needed to change that. It stays flat, it stays aligned really, really nicely. So there we go. First impressions, first thoughts. I really like it. It's a great machine, and I'm planning on it paying for itself hopefully very soon. So thank you all very, very much. I know I asked a lot of listening from you here, so if you made it to this point in the video, congratulations, you are a champion. Until next time, please do subscribe to the EcoStruder. You can also follow me on social media, where I post a lot of stuff about eco-friendly 3D printing or just interesting 3D printing things, stuff that I've been doing, things like that, teasing new videos as well. But yeah, with that, I just want to say thank you very much, and I really appreciate you watching. Have a great one. Bye.